Hello guys, so welcome to our last part of lecture 6, and we'll continue with our interesting examples. So last time in example 2, we see a circuit with two reverse bias diodes, okay, and the reverse voltage was 90 volt, okay, and the breakdown of these two voltages was 100 or minus 100, okay. So the input voltage was not enough to drive them into, or any of them into breakdown. Okay. In example 3 that you can see on the screen right now, okay, we changed it. It is the same example as example 2, but we changed the input to 110 volts. So we increase it by 20 volts. Okay. So everything is the same. You know, same characteristics, same diodes, but now the battery become 110 volt. Okay, so let's examine with 90 volt what was the operating point of each one of the diode. What was ID and VD for each diode. So let's change the color here to green, for example, and locate that on the characteristics of each. So from last time with 90 volt, VD1 was minus 89.982, and the current was 1 microamperes. So it's something, just a sketch, something like here. Okay, so this is VD1 was minus 89.982, and the current was minus IS1 minus 1 microamperes. And the other guy was minus 1 microampere. So here, minus 1 microamperes. And the voltage, was very small. Of course, this is not a scale drawing, but something like minus 0.018 or 18 millivolt. Okay. Good. Then we increase now the voltage into 110. Remember last time we said that for each one of the diodes, they are either operating in region 1 when VD and VT are comparable to each other, so the exponential will not be 0, or region 2 in which the current is known, minus I naught or minus IS, or region 3 in which we are in breakdown. Okay, and we make these combinations. Okay, we have two diodes, each diode has 3 possible region of operation. So we have overall 9 possibilities, 9 combinations. We cannot go, these are all the combinations that we can have. There are no other, other possibility rather than this. This is our whole space, we can say. And why they are 9? Because we have 3 possibilities for each diode, and we have 2 diodes. So 3 to the power of 2, which is 9. That's why we have 9. How many possibilities? How many operating region? Okay. And to the power of the number of diodes you have. Okay. So last time, since the input was 90 volt, and to go into breakdown, the source must provide the enough voltage for the diode to go into breakdown. The diode cannot drive itself into breakdown. It needs all the time a source that give the diode its V breakdown voltage, which is minus 100, so it can go into breakdown. So that's why we just exclude any combination that has region 3 in it. So we excluded this one and this one, this one. We also excluded this one because D2 in breakdown, and also exclude this one because again D2 is in breakdown. Okay, but now in that example we increased the input into 110. This is more than the breakdown voltage by even 10 volt. It's not just even on the edge of the breakdown of V. It is exceeding V breakdown. So we will get back to our possibilities, and might be one of those is correct. Okay. And as I said in the last lecture, guys, or the last video, most of the time you can guess the correct combination, just by studying, analyzing the inputs that you have. Okay. So from our key here is that basically this still reverse bias. Okay. And at the same time, we knew the operating point of for each diode when the input was 90 volt. When the input was 90 volt, VD1 was minus 89 point something, and the other guy was just 18 millivolt. Very far away from the breakdown. It needs it needs more than minus 99 volt, so that it can go into breakdown. Also, D1 only needs, around 11 volt or minus 11 volt, to go to breakdown. It's currently minus 89 something. So it just needs around 90, we can say. So it needs only 10 volts to reach the breakdown. And we increase the input by 20. So there is a great possibility that with our new input value, which is 110, that D1 will go into breakdown. And once it's in breakdown, it will have a constant voltage of a minus 100. Then the rest of the input, because of Kirchhoff voltage law, will go to D2. So VD2 will be minus 10. And minus 10 is much, much greater than VT. So that when you do exponential minus 10 divided by 0.018, this will give you around 0. So we will go into region 2. So looks like the correct guess here is that D1 is in breakdown and D2 in region 2. So D1 in breakdown, which is mean region 3, and D2 in region 2. So looks like this guy here, in which D2 is in region, let's go back to the color, now normal color. So looks like that D2 here will be in region 2, at the same time D1 in region 3. So looks like this is our candidate here. This is just based on our reading for the inputs and our previous experience with such circuit. So this is our best candidate or best guess. Of course, we are not sure. We must solve and see. Okay, good. So let's assume that. So let's assume from the beginning that D2 in region 3, which is breakdown, and sorry, D1 is in region 3, which is breakdown, and D2 in region 2. So assume. So let's write this based on the givens of the circuit, which is D1 and D2 on reverse, and also D1 and D2 characteristics. And our previous experience of the circuit at V input equal to 90 volt. Based on that, looks like D1 in breakdown or region 3 breakdown, and D2 is in region 2 is the best assumption to start with, or the best guess. Okay, so assume, again, we are not sure, we must solve and compare our results with our givens, our main vision or our main facts about this circuit. Assume D1 in breakdown, which is region 3, and D2 is region 2. When we assume that D1 is in region 3 or breakdown, that means for sure that VD1 equal to minus 100, which is the breakdown voltage of D1. And from that, and the Kirchhoff, we know that 110, which is V input, plus VD1, which is minus 100, plus VD2 equal to 0. So VD2 will be equal to minus 10. This is one of our unknowns. So now we know two unknowns. VD1 is known now, and VD2 is also known, minus 100 and minus 10 volt. Also, since we assumed that D2 is in region 2, that means that ID2 equal to minus 2 microamperes, or minus IS2, which is minus 2 microamperes. And we know from KCL that ID1 equal to ID2. So ID1, I'm sorry, equal to minus 2 microamperes. And the check now, okay? To check, one check is that just to calculate ID2 from the equation. So ID2 equal to IS2, which is 2 microns, exponential VD2, which is minus 10 over VT minus 1. If we just compensate, this is 2 microns, then exponential minus 10 over 0.018 minus 1. This is minus 2 microamperes. Just like what we concluded before. So everything is matched now. One last thing here is that if we look at the characteristics again, okay, and let's see if our let's do with another color. If our characteristic or our new operating points are matched to the characteristics. So in these characteristics, when D1 is in breakdown, we are region 3, we are here, okay, and the current was minus 2 microamperes. So remember, this is the first point here at breakdown, has IS, which is minus 1 microns. So now we become 2 microns, something like here. So this is minus 2 microampere. So yeah, when D1 is in breakdown, it can have a current of minus 2 microamperes, which exceeds minus 1 microamperes, which is correct. I mean valid. Okay, because in breakdown the current starts to increase than what? Then its previous value in region 2, which is IS1 for D1, of course. And for diode 2, we are operating in region 2. So the current is minus 2 microamperes, and the voltage is minus 10, something like here. Just a sketch. So minus 10 is much larger than VT. Remember, VT is just 0.018. So 10 divided by 0.018 is very big. If it's just 0.01, it will be 10 to the power of 3, 1000. So maybe 10 divided by 0.018 is around 500, maybe more than 500. So VD2 is 500, more than 500 times VT, which is for sure when you do the exponential, it will be minus 1. It will be extremely small number, 10 to the power minus, 20 or 30 or 40, something like this, which is 0. So yeah, we are in region 2. Okay. Now, one may say, no, I don't like that. I like to waste my time. And, I'm going to go over all the possibilities. So we finished this solving the solution now. I'm sorry. Yeah, we finished solving the problem. Okay. So we assumed from the beginning, something that we believe would be correct, and we proved it's correct. If you want to go for each, a combination, I mean D1 and D2 in region 1, region 1, region 1, region 2, and so on until you reach 3 and 3, you can do that. And I will do that now with you to convince you that each combination that you assume other than this one that proves to be correct will be wrong. Okay, so let's start by the first one. So solution here is complete, and the operating point for VD1 is, or D1 is, VD1 is equal to minus 100 volt, ID1 minus 2 microampere, VD2 is minus 10, ID2 minus 2 microamperes. Okay, now I'm gonna put a line here. Okay, and do some checks for you. Let's assume the n correct combinations and prove they are wrong. As I said, we finished. Okay, I will just convince you now that all the other combinations are wrong. And if you started with any of them, okay, you can prove easily that they are wrong. So let's divide here into 2 halves like this. Okay, so let's start with the first one. Assume D1 and D2 in region 1. So this is region 1 here for D1, and this is region 1 for D2. In region 1, usually VD is comparable to VT. Okay, very small than VT. Okay, so in your calculator, if you do exponential minus 10, it will be 0, or extremely small number. Okay, If you do minus 100, okay, it will be, you know, zero for sure. Just I mean, it will give you zero, not even a small number. Okay, so if we assume any which is not comparable to VT, okay, so with comparable numbers to VT, let's say VD is equal to VT, okay, so with that you have 110 as a source, and you have two diodes, each one is taking VT 26 millivolt, and for sure 110 plus 26 minus 26, because this is a reverse bias voltage, minus 26 will not give you zero, right? Because Kirchhoff voltage law is a fact. It must be satisfied each time for each circuit in the world, in history, and in the future as well. Okay, you know, Kirchhoff voltage law is a fact. You have a source. This source is a source, so it gives, you know, other. It must be distributed for other between other elements in the circuit, such that, you know, the total, the energy, the input energy is equal to the distributed energy. Each one of the sources of the diodes will have some sort of energy, so you have equilibrium. Okay, so even if we assume, you know, 1,000 volt, or even if we assume that VD1 equal to VD2 equal to 1,000 VT, okay, that means that VD1 equal to VD2 equal to 26 millivolt. Oh, I'm sorry, 26 volt, because 26 minus 1,000 times 26 milli will go with 1,000, it will give you 26. So still V input plus VD1 plus VD2 minus, this is minus 26. Okay, will be equal to will not be equal to zero, because this is 110, this is 26, this is 26. I'm sorry, minus 26 and minus 26. This is not equal to zero. Okay, even with 90. And in region 1, basically, you know, D1 and D2 cannot reach even minus 1,000 or even minus 10. Okay, it will be much smaller than this. Let's say 10, even with 10. So if the VD1 is 10 VT, it is 0.2, you know, 6 millivolt, and the other one will be 0.26 millivolt. So still 110 minus 0.26 multiplied by 10 to the power minus 3 to convert it from milli to volt, minus 0.26 multiplied by 10 to the power minus 3 to convert millivolt to volt, is still not equal to zero. So that's basically incorrect assumption. Let's assume another one. So this is wrong one. Assume, let's go back here and see. So this is incorrect. 1 and 2. So D1 in 1, D2 in 2. If D2 is in 1, if D2 is in region 2, that means ID2 equal to minus IS2 minus 2 microamperes. If D1 is in 1, that means that ID1 is less than magnitude as a magnitude one microamperes. And remember, from KCL, ID1 here in that circuit equal to ID2. But from this, these are contradicting, because ID1 is equal to ID2. ID2 is minus 2 microamperes, and the magnitude of 2 microamperes is larger than or greater than 1 microamperes. So this is again wrong, because assuming that D1 is in 1 and D2 is in 2 will lead to incorrect consequence in which ID1 is greater than 1 microamperes. It will be equal to 2 minus 2 as a magnitude will be 2. 2 is greater than 1 and it should be less than 1. Number 3 is the assumption. So this is again a wrong one. Now 1 and 3 assume D1 in 1, D2 in 3. That's very easy one, okay? If D2 is in 3, which is breakdown, that means VD1 equal to minus 100. Sorry, VD2, which is breakdown, right? Okay, that means, also that means that ID2 as a magnitude is greater than IS2. That means it should be greater than 2 microamperes. But remember, D1 is in region 1. So from this, ID1 as a magnitude should be less than 1 microampere. Okay, and ID1 equal to ID2. This guy is greater than or equal 2 microamperes because it's in a breakdown, and this guy is less than 1 microampere. So again, there is contradiction. So this is also incorrect. Let's continue. Now we go to region 2 and let's do it in another. So let's assume number 4 here. Assume that D1 is in 2 and D2 is in 1. D1 is in 2, that means that ID1 equal to minus IS1. Okay. This is, by the way, same assumption that was correct when the input was 90 volt, and it was correct at that time. Here it's not correct, and we're gonna prove that now. So ID1 is equal to minus IS1, so minus 1 microamperes, and D2 in region 1, so ID2 is less than as a magnitude 2 microamperes. So far so good, because ID1 is equal to ID2. Okay, ID1 is minus 1 micro, so ID2 as a magnitude equal to 1 micro, which is less than 2. So ID2 equal to ID1 equal to minus 1 microamperes. So the magnitude of ID2, which is 1 micro, is less than 2 microamperes. So far so good. Okay. Since ID2 is known now, minus 1 microamperes, we can calculate VD2. So VD2 is equal to VT ln ID2 over IS2 plus 1. And from that, VD2 is minus 18 millivolt or 0.018 volt. Okay. Then from KVL, VD1 is equal to minus 110 plus, just make it yourself. Okay, it will be minus 109.982 volt. And this is basically incorrect because as a magnitude now, VD1 is equal to 109,982. That's bigger than V breakdown, which is 100. And remember, we assume that D1 is in 2, not 3. It's not a breakdown. So basically, it cannot exceed 100 as a magnitude, or minus 100 as a value. So that's also incorrect assumption. Okay. Now, let's assume another one. Assume D1 is in 2, D2 is in 2. If we assume that D2 is in 2 and D1 is in 2, so that means that ID1 equal to minus IS1 minus 1 microamperes. And if we assume D2 is in 2 as well, so ID2 equal to minus IS2 equal to minus 2 microamperes. And remember, ID1 should be equal to ID2, but these are not equal. That violates the fact that ID1 is equal to ID2 based on KCL. KCL is a fact, or KVL is also a fact. So that's also incorrect assumption, right? Very easy. Number 6. Assume D2 is in 2 and D1 is in 2 and D2 is in 3. That's an easy one, okay? So if D2 is in 3, that means VD2, which is breakdown, that means that VD2 is equal to minus 100. Minus 100, okay? And ID2 is greater, as a magnitude, is greater than 2 microamperes. Okay? Because if we go back and look at the characteristics, if D2 is in breakdown, so its current will be for sure as a magnitude larger than minus 2. It will exceed going down minus 2. But D1 is in 2. So ID1 equal to minus IS1 equal to minus 1 microampere. And the ID1 should be equal to ID2. So, but ID1 is equal to minus 1 microamp, So ID2 is equal to minus 1 microamperes. So ID2 will be equal to also minus 1 microamperes, but this is less than as a magnitude this is less than 2 microamperes. So violation. So that leads to another violation, that we are saying that D2 is in breakdown. That means that ID2 as a magnitude exceeds 2 microamperes, but at the same time ID2 is equal to 1 microamperes, which is less than 2 microamperes. So again, that's incorrect assumption. Number 7. Assume D1 in 3 and D2 is in 1. That's maybe close to our solution. Okay. Our solution, remember, was D1 in 3 and D2 in 2. Okay. So let's go with this. So D1 in 3, that means VD1 in breakdown. So VD1 is equal to minus 100. And for sure, ID1 as a magnitude exceeds 1 microamperes. D2, so since we know VD1 is equal to minus 100, so we can determine VD2. So VD2 is equal to V input, I'm sorry, minus V input, which is minus 10. Do it with Kirchhoff voltage law, you will get this. Plus 100, which is VD1, minus VD1, will give you minus 10. Since we get VD2, we can determine ID2. So ID2 is equal to IS2 exponential VD2 over VT minus 1. Do that, you will find that is approximately equal to 0. So this will give you minus IS2 minus 2 microamperes. And remember, when we are in region 1, okay, IS or ID should be less than the 2 it's a saturation current, the magnitude. It should be less than 2 microamperes. Okay, so that's, you know, that will give us a clue that we are really in breakdown, but D2 is in 2, not 1. So this is another assumption that you may assume in the beginning, because it's a good one. It's not that bad. And once you see this, you will notice, oh, it is, so maybe it's really in D1 in breakdown, but D2 should be in number 2. So basically here there are 2 guesses, you know, that you can start with, although still one of them is wrong, which is this one. D1 is 3 and D2 is 1. Okay. But this assumption that I just proved, you know, wrong or not accurate, we can say, okay, will lead you to the most correct one, which is D1 in 3 and D2 is 1. One may say, maybe it's 2 and it's working just, I mean, for D2, just working here, you know, at this transition point. That's also good, you know, good observation. Okay, it might be. Like actually both leading to the same result. But it's for me, it's much more safer to assume that D2 is in region 2. Okay, away from region 1, because again, region 1 basically, you know, you will find that the values for VD is comparable to VT. Okay, so that's also not correct, because in region 1, D2 should have a current, you know, so this means ID1 as a magnitude, I'm sorry, ID2 as a magnitude should be less than 2 microamperes. But here it's equal to 2 microamperes as a magnitude. Okay. So the next one is the correct one, which is D1 in 3 and D2 is 1. So we have the solution already. This is our solution. So the number 9 now, assuming that D1 in 3 and D2 is in 3 as well. Both are breakdown. Both are breakdown. That means that VD1 is equal to minus 100, VD2 equal to minus 100. And this is very easy to disprove or prove wrong, because basically V input from KVL, which is a fact, plus VD1 plus VD2 should be equal to 0. But what we have basically is minus 110, minus 100, minus 100 equal to minus, I'm sorry, this is plus. So this will give us minus 90. This doesn't equal to 0. That's also, you know, proof that this is a wrong assumption. Okay, guys. So this is basically, you know, all the assumption, and I showed you that all of them is wrong except the first one that we assume from the beginning. Okay, and you know, by the time when you train yourself a lot with these examples, you will get, as I said, you will get to the correct assumption maybe most of the time from the first time. Okay, guys, thank you very much and have a great day. Bye-bye.